Okay, so the fact about the camel says, camel having the flat and broad feet. So suppose here we have the feet of the camel. Okay, so its feet is like this. Okay, so due to that broad surface, okay, here we have the sand, here we have the sand. Okay, so due to broad feet and flat feet, it will sink only little in the sand, hence the camel can walk easily on the sand. Okay, yes, it is also called as the shape of the desert or shape of the sand, right? Okay, so now we are going to start the variation of pressure. Variation of pressure. Okay, see, pressure depend on two main factors, beta. Two main factors. What are these two factors? Increasing the force on an area, increase in the pressure. Okay, wait a second now. Someone is in waiting room.
Sir, there is a little disturbance from. Yes, sir.
Okay, see, variation of pressure. So pressure mainly depends on beta two factor. What are these two factor? First, increasing the force on the area, okay, increase the pressure. See, suppose if you are discussing about, suppose this is the any surface, okay, here we have any surface, and if we are applying pressure here, okay, with that particular nail, okay, suppose whatever the force is acting here, suppose we are applying 1 Newton of force on here, okay, and the pressure, let it is 100 bar. We are just taking example, huh? If suppose if we are going to apply more pressure force here, means now we are applying 2 Newton of force, so obviously that no pressure will also going to increase, is it? See, that's why the force is increases, pressure will also increases. So we can write here, force is directly proportional to pressure. Okay, if force will reduce or decrease, pressure will also decrease, or force will increase, pressure will also increase. So that's part you have to remember only. Force is directly proportional to pressure. Directly proportional means whatever the effect is going on the force, same effect is going on pressure also. If it is going to increase, that another property is also going to increase. If it is in decrease the force, okay, pressure will also decrease like this. So that relationship is called as what? Direct relation.
Sir, and for area, can I say, sir?
Yes, we are going to cover that.
Yes, sir. It's inversely proportional.
Yeah. Okay. So this is the first factor on which the pressure varies on force. Now, second, similarly, increasing the area. Okay. Suppose 1 Newton of force. Now we are keeping the force constant here. Okay. We are keeping the force constant. And if we are reducing that area, okay, suppose first we are having that much area, okay, like this, but now we are having the pointed area, okay, so here the area is reducing, so due to reduce of area, pressure is going to increase, but condition is there, force will remains constant. If same force we are applying on the both, so more pressure is going to act on the pointed area, means area is less. Okay, similarly increasing the area over which a particular force acts decreases the pressure. Okay, so second relation I am going to write here, if we increases the area, okay, so it is inversely proportional to the pressure. If we increase the area, that means pressure is going to decrease. If we will decrease the area, then pressure is going to increase like this. So it is inverse relation. Inverse relation in which, okay, if one quantity increases, other quantity decreases. If one quantity decreases, other quantity will increase. So this is the inverse relation. So what are the two factors? One is force, force, applied force, and other one is, so I'm writing here force and area. These are the two main factors on which the pressure depends. Understood, everyone? Do reply, beta.
Yes, sir.
Yes, sir.
Yes,
Okay.
Yes, sir.
Okay. The converse is also true. That means if we can say pressure is inversely proportional to area, we can like write also like this. Okay, if we'll increase the area, pressure will decrease, or if we'll decrease the area, pressure will increase like this. So this is inverse.
Also, it is opposite, sir. When
Yeah,
area will
yes,
increase.
yeah. Okay. Decreasing the area over which a particular force act increases the pressure. Okay, these are the two relations that you have to remember. Just think opposite. For example, the pointed end of the high-heeled shoe exerted a greater pressure on the flat end, okay, than the flat end, and the force. See, suppose for women's, or we can say girls, they used to have the sandal having. Suppose this is the sandal. Okay, this is the sole area like this. Okay, so see, they used to have the high heel like this. Is it or not? Okay, so if this area is less, so it is going to apply more pressure. If the same sandal, if you have the broad base like this, so it is going to apply less force on the ground. Is it, everyone?
Like shoes. Sir,
Yes,
we are
yes,
going
yes.
to learn the laws of motion.
Here, if we'll have, we will do that also.
So like that. For
Law of motion is not in this chapter, no?
I think we have that in syllabus. That's all.
Okay, we can cover that also, don't worry. Okay, so this is also the reason why needle are made with a sharp point. Okay, see, generally needle, by which we used to stitch the cloth, okay, have the pointed needle, so that if we'll apply less pressure or less force here, it will going to insert inside the cloth, okay, easily. Since the sharp point of the needle has a very small surface area, lesser force is needed to pass the needle through the cloth while stitching easily. Okay, if we'll apply only like little force here, okay, towards this, so here the direction of force, so that pointed needle is going to insert inside the cloth easily. That's why we used to keep the pointed needle in order to stitch the cloth. The same is true for drawing the pins. Okay, drawing pin also. Okay, they are also having very like pointed end over here like this. This is the drawing pin. Okay, then which are generally used to pin up the notice on the notice board. Okay, the drawing board or the drawing pin we are using generally in order to like that keep the notice on the notice board. We use pin up that over here. As you can see, this is the
For
over
attaching
here.
the paper.
Yes. Pin up the notice board on notice on the notice board. Okay, so this is all about the variation of pressure. Any doubt here, beta? No, na? Okay. So now we are going to understand the fluid pressure. Very important that again. Fluid pressure. Okay. See, liquid and gases are together called fluid. Why? Anything that can flow is called as beta fluid. So liquid as well as gases, okay, are together called as fluid. Fluid exerts the pressure on the bodies immersed in them and on the wall of the container that hold them. Okay, suppose you have empty water bottle. Oh, wait a second. Okay, suppose this is the empty water bottle. Okay, and here we have the cork. Okay, here there is no water. And if you are going to deep, inside the water. So here we have the water. Okay, so see that water particles are going to apply pressure on the wall of that container. Okay, from outside. If again same example but in a different way. Okay, if we have water inside the bottle, so again that water is going to apply pressure on the inner wall of the container where it is being held. Okay, so whether it is liquid or gases, they apply pressure on the container from outside as well as from inside. They apply the pressure from inside if it is a container and where water or gases is being filled. Okay,
Sir, but not that much pressure, right, sir?
Amita?
Not that so much pressure, only less pressure only, right?
No, beta. If water is more, suppose, see, why that overheaded water tank, okay, we used to like fill water, okay, on the floor, having very large, the broad wall of the container. Why? In order to withstand high pressure. Okay.
So it also depends on the amount of fluid, sir. Like
Yes,
for example,
amount. Yes, it depends
sir,
on
if you go,
amount of fluid.
sir, if you
Yes.
swim into the ocean and you go deep, sir, you might
Yes,
die
yes.
because of the pressure.
Yes, have you watched that movie called Ghazi Attack?
No, sir.
Where,
Yes, sir.
where in movie, that Indian Navy, they used to like go inside the ocean again and again, deep and deep. So the wall of that submarine was also about to like shrink over here due to the high pressure applied by water. Okay, so this is, so if you are going deep again and again, so water is going to apply more pressure. So at the deep, like pressure is very high, at the above that it is medium, and at the top it is very low. We can say that. Okay, let's discuss next. This is why the balloon, see, if you are filling the air inside the balloon, okay, suppose this is the balloon, and if you are filling air inside it, so size of the balloon is going to increase like this. Okay, why? Because air exerts pressure on the wall of balloon and it makes it to inflate. Okay, so this is why balloon used to get inflate, okay, when we are filling air inside. Okay, so balloon expand when we blow air into it. The air inside the balloon exert pressure on the inner wall of the balloon. Okay, it exert inner wall of the balloon. If we blow too much air, the balloon is going to burst. The material of the balloon is not capable to withstand at that particular pressure. Okay, on expanding further, it is going to burst. Okay, increasing the pressure inside can cause the wall of the balloon to break one or more points from at one or more point, and the balloon will burst. This is why balloon burst when too much air is blown into it. Okay, so here we have the example of the balloon. Okay, now discuss next. When an object is immersed, if same balloon, if we are going to immerse inside the water, okay, so water now going to apply pressure from outside. Okay,
Immerse means like into it, right?
yeah, if you are immersed, like we are like we can say sinking the balloon inside the water. Okay. Yeah, the liquid exert the net upward force on the object. If you will blow like you will keep the balloon on your hand, and if you are like sinking inside the water, so you have to apply more pressure, because water is going to apply pressure on the balloon against your force. Okay, so probably that balloon again going to reach on the surface, as you can see. Okay, if you try to push inflated balloon into the bucket of water, you will find that as you try to push down the balloon, okay, the water seems to pushing it back upward side against you. Okay, if you will try to deep balloon inside the bucket, okay, water will going to push that balloon in upward direction. means that force works against your force. Okay, if you stop pushing the balloon will push back to the surface, and this is because the water in the bucket exert pressure on the wall of the balloon. That's why it is going to like float on the surface of water.
Because it has less density.
Yes. It's not like density part, but it is the pressure part.
The
Water
pressure
is,
applied by water.
yes. Water is applying pressure on the wall of the balloon. That's why it is coming outside. Okay. This upward force exerted by the liquid determines whether the object will float or sink in the liquid. Okay, that amount of water, like amount of force which is going to apply on the wall of that particular balloon or any container, it decides whether objects are going to sink or going to swim.
So
Okay,
I have a doubt, sir, for this.
uh-huh.
This comes in under the kg to Newton value, right, sir? 9.8 newtons equals to 1 kg.
Yeah, this is nothing but the universal, not universal Gaussian constant. It is called as acceleration due to gravity. It is 9.8. G is
9 point.
Yeah.
Sir, but does that work for this as well? Like, sir, for example, if the
See,
pressure being
if
exerted by the
suppose-
water
see,
is
suppose, wait. Suppose here we are the balloon. So Earth again going to attract that balloon towards it, right?
yes, sir, through gravity.
Yeah, but water is going to push that balloon in upward direction.
Yes, sir.
Yeah, so the force exerted by balloon water on the balloon is more as compared to the gravitational force. That's why balloon is going to sink on the surface of.
So, sir, that's what. So,
float.
this is what determines buoyancy, right, sir? Floating or sinking.
Yes, it is called as buoyancy and upthrust force. It is called as upthrust force.
Okay, sir.
That means the force is normal.
Yeah, suppose here we have the iron block, iron block of 5 kg. Suppose it is the iron block of 5 kg. Okay, if we will like throw that 5 kg iron ball in water, it is going to sink. It will settle at the bottom.
Yeah, because it's
Yes, surface area is very low. But by using the same 5 kg iron, if you will make a small boat, okay, small boat by using that, okay, so that boat is going to swim. Why? Because when we have converted that 5 kg of iron into boat, we have increased the surface area.
That area is more and pressure is less.
Yeah. So more surface, more area, so more will be the opposing force applied by the water, which is called buoyancy or buoyant force. So more surface area, more will be the buoyant force, and that buoyant force decide whether the object are going to sink or swim. Okay. If upward force exceeds the weight of the object float. Okay, see, suppose here we have, suppose instead of balloon here we have any iron ball. So iron ball's mass, okay, will be higher, okay, and area will be the less, so it is going to sink. But if when the applied force, see here balloon is, or that suppose this is an iron ball beta, so iron ball is also going to apply force, so I'm writing a force by ball. Okay, and again water is going to water is going to apply force on the ball, so I'm writing a force of water. Is it? So if force of water is greater than force of the ball, then it is going to swim. Okay, if water force is greater, so that object will going to like present on the surface only. But if force of the water is less than force applied by the ball, so it is going to sink. Okay, and if force of water is equals to force of the ball, so it is going to like you can say submerge. Submerge means half will sink and half will at the inside the water, like this. So it is going to submerge, not going to sink. Understood that concept? Very important, everyone. Everyone?
Yes, sir.
Yes, sir.
Okay. So if you have any questions regarding that, you can ask the question now. Now we are going to start atmospheric pressure. Very, very important again. Okay. What is atmospheric pressure? The pressure applied by atmospheric air on the wall of like any container or human being or our body is called as atmospheric pressure. Okay. Generally, it is been measured in ATM. ATM. ATM is nothing but one of the unit of atmospheric pressure. ATM is called as atmospheric pressure. Okay. Let's understand from the notes now. Did you know that all of us are immersed in the sea of air? Yes, we are in the sea of air. Is it or not? Because we have all air, like all around us, air only, where 78% is nitrogen. Okay, 21, it is like not 21, it is 20.95% of oxygen. Then rest other gases, including carbon dioxide, methane. Okay, so
Argons.
yes, so we are on the ocean or at the bottom of the ocean of air, sea of air or ocean of air. And if we are, suppose here we have the earth surface. Okay, so here we have the atmosphere, and atmosphere we have air only. And if we are here, that means atmospheric air is applying pressure from all sides on our body. Okay, so we are experiencing the pressure all the time. This is called as atmospheric pressure. You won't feel that, but yes, we are experiencing the atmospheric pressure. Okay, because we used to that, because since the birth, okay, till the death, we are in that particular air only. That's why we won't feel, okay, but we are on the pressure of the air. Scientists discovered atmospheric pressure in 17th century. When in 17th century, this discovery uncovered an interesting facts that are actually has weight. Okay, that see, if pressure is going to apply on our body, that's why we are on the surface. If there is no force, like no gravity, no atmospheric pressure is going to work on us, so we will feel like weightless. We will feel like weightless. Okay, the weight of the atmosphere pressure down on the earth's surface and creates a pressure on it. Okay, see, that pressure again, that air also going to apply pressure on the earth's surface also, and due to which air reaches all over the underground also, all over the ground, even underground where it makes any passage, so air is also present inside the earth. Okay, because air is present all around the earth and it applies force on that. That's why all the like objects, they are stick to the earth only. Okay, atmospheric pressure is defined as, so now we are going to understand the definition, very important. Defined as the pressure exerted on the object by the weight of the air above it is called as atmospheric pressure. Okay, so whatever the weight of the air on the wall of container or any object or on our body is called as atmospheric pressure. The atmospheric pressure on the earth's surface at the sea level is about 100. Very important. Okay, just do remember. Okay,
That is 100,000 Pascal.
yes. Okay, oh yeah, 100,000 Pascal. Sorry, I haven't gone through whole part. Okay, so the atmospheric pressure on the earth's surface, see, it is on the Pascal beta. But if you will study in ATM pressure, so it is considered as 1 ATM pressure, and 1 ATM pressure is equals to 100 K. K is kilopascal, 100 kilopascal.
So that K means 1,000, I think, right? 100,000.
Yeah, 1,000 means K is the 1,000, no?
Yes, you said
Yeah.
something.
Yeah, 100 kilopascal. K is nothing but for the thousand. See, 1,000 gram equals to 1 kilogram. So kilo is going to use na, that K is represent as kilogram. So we have, this is the pascal and this is kilopascal. Okay.
So it's kilopascal.
Yeah. So 1,000 pascal equals to 1 kilopascal. Okay. Like take example of distance. So meter and kilometer. So 1,000 meter equals to 1 kilometer. 1,000 gram equals to 1 kilogram. Likewise, 1,000 pascal equals to 1 kilopascal. So it is 100 kilopascal. Okay.
Sir, it's saying 100,000 Pascal, right?
Generally, 1,000 is represent as kilo beta, kilo. Have you bought any vegetable from the market? Like suppose Ritvik is going for buying vegetable for his home. So now Ritvik at in front of the potato shop. So Ritvik, what you will ask to the shopkeeper? What you will ask?
So kg potato.
Yes, 1 kg of potato. So 1 kg means it is 1,000 gram. Kilogram is 1,000 gram. Yeah. So instead of 1,000 pascal, we had to use kilopascal beta. Okay. Yeah. So, okay, if such an enormous amount of pressure is acting on us, okay, so 100 kilopascal of the pressure is acting on our body also. Why do we not feel it? Because we used to it. And again, one more important thing, the blood stream of our body, they are carrying the blood, they can withstand. Okay, they are also going to apply pressure on the blood stream like arteries and vein. Okay, so our body structure has formed in order to withstand that particular pressure. But suppose if I will keep you in the space where there is no atmospheric pressure, so all the arteries, vein, hearts are going to burst, okay, due to high pressure, because there is no against pressure is going to work on our body.
So there's actually a fact about this. The reason
Yes.
babies cry when they are born, sir, is because the air pressure crushes their lungs in the beginning, sir.
No, not like that, beta. It is
So no, the air they breathe for the first time, sir, because of the air.
Yes. In order to breathe first time, they have to cry.
Yes, sir.
Like that.
And that's they breathe the first time because the air is forced into their lungs through air pressure, sir. Atmospheric pressure.
They have to cry. That's why air reaches, rushes to their lung and they can start breathing. That's why it is very important and necessary or mandatory to cry baby after the birth, just after the birth. Okay.
So then they get used to it.
Yeah, then they can breathe easily. Okay. So this is because the pressure of the blood in our blood vessels and that of the other fluid present in the body balance out. Okay, because we are not feeling that 100 kilopascal of pressure, because there is a pressure inside our body also, and our body pressure and air pressure, they balance each other. That's why we are not feeling the atmospheric pressure. Understood? This is the reason for that.
So like they cancel out, you mean?
Yeah, they cancel each other, or we can say they balance each other. Yes. Okay.
So like the water particle you explained.
Yes. Atmospheric. Wait. Atmospheric pressure is measured using the instrument called barometer. So which instrument or device we are using to measure the pressure? Barometer. Okay, barometer is the device which is used to measure the pressure. Understood, everyone? Very important. Even if you are feeling the you are trying to feel the air in your bicycle's tire or like moped or car tire. So the device which is used to fill the air called air pump, which also connected with the barometer, right everyone? In order to measure the pressure inside the tire or tube. Is it or not? Keep replying, beta.
Yes, sir.
Yes. So this is the barometer. As you can see in diagram here, we have the barometer. That one. Okay. So wanna have quizzes?
Yes, sir. Sir, give them
Go through
some
this